Right, so up to part B of test D, more evaluation. So we know we're going to have a value as the answer. So A is 3, B is 5, C is 2. What is 2A plus C? A is 3, so you're just going to go 2 times 3 and then add on 2. So that's 6 plus 2, which is going to be 8. That one's pretty easy, isn't it? Is that one all right? B squared, so I just put that in brackets, that's 5 squared, plus 2 times A is 3, times C is 2, minus 4. Just evaluate each bit first before you join them together. So 5 squared, that's 25. 2 times 3 times 2. Well, 2 times 3 is 6, times 2 is 12, minus 4, and then you can do it all together. 25 plus 12 is 37, minus 4. Whoop, I'm writing 34, but I'm saying 33 in my head. That's really funny. It's because I still said minus 4, so my hand started writing a 4. Not too bad. Same one again, substitution, B times C. So it's 5 times 2 minus 2, all divided by 4. That's 10. Take away 2 divided by 4. 8 divided by 4, which is just 2. And lucky last, they've just got more bits to it, but they all work the same way. This is going to be 8. Replace the C with a 2. Multiplied by B is 5. A is 3, and I've got to square it. Plus 24. Okay. 8 divided by 2 is 4. Times 5, and 3 squared is 9, plus 24. 4 times 5 is 20, times 9 is 180, plus 24, 204. So it might take you a little bit longer to do the multiplication than what I'm doing there, but the actual process is easy enough, isn't it? Find the numbers, multiply them together, get the answer. These ones were interesting. Simplified by cancelling. What are the only things we're allowed to cancel when we're dealing with fractions? Like terms are the things we're only allowed to add and subtract. Cancelling, when we're cancelling, remember it's common, nearly common factors. So you've got to make sure the top and bottom are things being multiplied together before you simplify. As long as they are, it becomes really easy. This first one here, 45 and 5, 5 goes into both of those numbers, doesn't it? It goes into this one once, and how many times does 5 go into 45? 9, beautiful. Then you just get to your letters. On top, I've got 3 A's being multiplied together, and on the bottom I've got 2. So I can cancel 2 of the A's down the bottom, with 2 of the A's up the top, which is just going to leave me with like A to the power of 1, isn't it? And then how many B's can I cancel? I've got 4 on top and 1 on the bottom, so I can only cancel 1. The 1 on the bottom cancels with 1 of those B's on the top. So in the end, I've got 9 A to the power of 1. I don't need to write to the power of 1. And B to the power of 3. And that's my answer. I'll show you the same thing for the next one, except what I'll do before we multiply it is I'll write it out in what they call expanded form. For some of you, if you are having trouble just looking at the number using the index, you can always do it this way. For some people, this makes the cancelling easier. So where I have a T and a T, that's the same as multiplying by 1, isn't it? T divided by T, that's like 1. T divided by T, well, they can go to 1 as well. This remaining T up the top doesn't have anything to cancel with. But look, I've got an S on the top that can cancel with one of the S's on the bottom. And 81 divided by 9, well, 9 goes into 81 9 times. So that's an alternative working if you find it easier to write it out in expanded form. Obviously, if the powers are like 160, you don't want to be doing it that way. But for now, if that makes it a little easier for you to see, I've got 9 times 1 times t, so that's just 9t. And on the bottom, it's just 1, so I don't need to write the denominator in there. These next 4, I'm just going to go through the motions of cancelling it out, but I won't talk about it, and see if you can fill in the blanks in your head as I'm going. See if you can understand what I'm doing each step of the way. So I'll start with the numbers. So, starting with the numbers, cancel the common factors, cancelled the common factors in the letters, wrote down the answer. It's exciting. Same thing with the next one. You guys see if you can do it. I'll do it without talking about it, so I want you guys to think about it as we do it, and then just match up and make sure you get the same as me. If you're watching this on the video later, just pause the video and then check my working and see if you get the same. That's good. If you're getting the same thing, that's good. So that talk that I usually do, I do that inside my head when I'm doing it. Okay, I'm looking at the numbers, what's the common factor, cancel it out. Looking at the letters, cancel it out. Same thing. The last 2, I'll just go through them both quickly. You guys can then compare your answers. So they're both negative. So negative 8 goes into that 9 times. Negative 8 goes into that once. Oh, there are no other letters to cancel. That one was actually really easy. Lucky last one over here. 9 goes into 9 once and into 36 4 times. There's a U on top, can cancel with a U on the bottom. A V can cancel with a V. W squared can cancel with W squared. Wow. Those last 2 had extreme cancelling. Is that good, Ashley? Nice. Oh, find the solution set that satisfies both inequalities. This is definitely harder than you'll have to do in the test, but I'll talk through it anyway because it's actually pretty easy. It's just a little bit more thought involved. Yeah. Sorry. Did you get 4? Nice. What have we done with Harper? Is he working outside or has he disappeared? Doing any maths? Probably are. Hello boys, have you ever watched this video? Alright, so this one here, find the solution set that satisfies both inequalities. He wouldn't be playing games, would he? Not Luke. He wouldn't do that. Love you too. Everybody love everybody, guys. It's important. Look, let's just rearrange each of these. It's okay. So what do I do first? Because some of us are still worried about these inequalities, but they work the same way. I want to get rid of the 3, so I subtract 3 from each side. 7 minus 3 is 4. Then I'm just dividing by 2, aren't I? X is less than 4 divided by 2 is 2. That's your first one. You do the same thing for the second one. So this time I have to do the opposite of subtracting 2, which is to add 2. So I'll have 2x is less than 10. And then when I divide by 2, I get x is less than 5. When they're saying find the solution set that satisfies both inequalities, you've just got to take the most restricted bit. So one of them, I could have any number less than 5. The other one, it's only any number less than 2. So to satisfy both, you must be less than 2. equations. I should write inequations because they are inequalities, aren't they? Erica, was that okay? I know you don't like them. It's good, isn't it? Yeah. Because all you have to do at the end there is just which ones satisfy both. So like one of them, it's x is less than 2. The other one, x has to be less than 5. So to make sure you fit both categories, you've just got to be less than 2. That's all you have to do. Let's rearrange this next one. So we're up to part B. I'm going to subtract 3 first. This time I'll put the little extra working steps in, just to show you that it doesn't hurt to do it. So now I'm going to have 3x is less than 15. What do I do to get rid of the 3 that's multiplying x? How do I get x on its own if I've got 3x? Divide by 3. Bang. So this one's x is less than 5. That's what we had before. Other side, what's my first step? Are they the same questions? Nearly, not quite. Okay. Just getting confused there. So, opposite of adding 3, subtract 3. That gives me 2x is greater than 4. Next step, to get x on its own, I divide by 2. X is greater than 2. So now I want the x values that are greater than 2 and less than 5. How would you write that? Well, x has to be greater than 2 and less than 5. And if you really like to do a solution set, you can put it in the fancy curly braces, but you don't have to. So the only numbers that would work are numbers that are bigger than 2 and also less than 5. So it's just the numbers between 2 and 5. Again, the little rearranging of each equation, I expect you to have to do that in your test. The actual finding a solution set that satisfies both, probably not, but it's actually not that hard, is it? You just figure out which ones work for both of them, that's your answer. Now this is good practice, the next part. Writing equations with a variable and then solving to find the unknowns amounts. So an unknown number, I'm going to call it n for number because I'm very creative like that, is multiplied, excuse me, multiplied by -4 and then divided by 7. That result is reduced by 3, which gives 9. Okay, let's see if we can do this. First of all, to multiply a number by -4, I could call that -4n, because that's multiplying, isn't it, when I write a number next to it? Then divided by 7. Okay, well, dividing by 7, I'd have to multiply before I divide. That's good. And that result is reduced by 3. Reduced is going to mean subtract, isn't it? It's going to be discounted, reduced by 3, and the result is 9. Now we've just got to solve that equation. What's the easiest thing to get rid of in that equation? What's got the least to do with it? Yeah. 3, yeah, absolutely. The opposite of subtracting 3, add 3 to each side. Perfect. So I'm going to have -4n over 7 equals 9 and 3 is 12. Now the next bit you can do in 2 or 1 step. You could just multiply by the reciprocal, 7 over -4, but would you rather do it in, who prefers to do it in 2 steps, who prefers to do it in 1 step? Okay, I think I'll do 2 because that's what most people seem to prefer, but if you do it in 1 step, good on you, because that will save you time overall and into the future. So I really don't like having a denominator, so I'm just going to multiply by 7. Multiplying by 7 on the left-hand side cancels out the denominator, and I've got -4n equals, and 7 12s are 84. Final step, the opposite of multiplying by -4 is to divide by -4. So we do that on each side, and we find the number equals -21, and that negative sign on the right-hand denominator didn't show up. That's a bit better. You can check it. Negative 21 multiplied by negative 4, that'll give me 84. Divide that by 7, it'll give me 12. 12 minus 3 is 9. Works when you check it, so you know you got it right. A couple more. We'll finish off these ones before we stop this section of the video. 8 more than double a number is divided by 3. And this equals in 34. That makes me nervous. They haven't got their wording right. It could be trouble. It could be another Jake and Jimmy question, which was trouble, wasn't it? Right, 8 more than double a number. So let the number equal n again. So double a number is 2n. How do I go 8 more than that? Plus 8. 8 more than double a number is divided by 3. So the whole thing is divided by 3. And I believe they're trying to say that's equal to 34. Now we just go ahead and solve it. What's got the least to do with my letter? The 2, the 8, or the 3? 3. So we get rid of that first, don't we? Excellent. On the left-hand side it cancels, so I've got 2n plus 8 equals 102. Subtract 8 from each side. And I have 2n equals 94, dividing by 2, n is equal to 47. 8 more than double that number, 94 plus 8, 102. Divide that by 3, and you get 34, so you know you got it right. Last one. Chloe is 5 years older than Mia, and Emma is triple Chloe's age. Double the sum of Chloe's and Millie's age is 1 more than Emma's age. What are their ages now? That's a pretty tricky one. I'm just going to use their first letter to be their age. So C is Chloe, M is Mia, E is Emma. Chloe is 5 years older than Mia. So Chloe's age is Mia's age plus 5. We can do that first, can't we? That's good. What else we got? We got Emma is triple Chloe's age. Emma's age equals 3 times Chloe's age. Then they give us another bit of information. Double the sum of Chloe and Mia's ages. So Chloe plus Mia. Double that sum, so times that by 2, equals Emma's age plus 1. So this is pretty tricky. We've got 3 different equations to try and solve. But we can still do it using substitution and it will work out just fine. Who's worried that it won't work out fine? Oh, Erica is just tired. Too much fun. Alright, I can clearly replace C with m plus 5, can't I? Let's do that in each of the other equations. So there's lots of ways you can do these, but seeing as though we know substitution is a method. So this time I've got 3 equations, which is what I need because I had 3 values I didn't know. I'm going to replace, so let C equal m plus 5 in 2 and 3. So then what I should be left with, so this is going to be E equals 3, and instead of C I write m plus 5. That's my new equation 2. My new equation 3 is going to be 2, and instead of C I write m plus 5 plus m again equals E plus 1. So I've rearranged, I've substituted that first equation into the other one. So now I've got 2 equations and 2 letters I don't know. So it's back to what we normally start with, isn't it? And look, it's already set up to substitute again. I've got an expression for E in terms of m. I know what it's equivalent to in terms of m. So now I'm going to say let E equal 3 outside of m plus 5 in equation 3. So I did one substitution, then I rearranged one of the equations, substitute it into the last one again. So now this one, 2m plus 5 plus m equals, and instead of 3, I write, instead of E, I write 3 outside of M plus 5 plus 1. Now I just work backwards. If I solve for M, I can work out, who is it, Mia's age. Then I can go from there to work back to Emma's age, and I can go from there to work back to Chloe's age. So let's just rearrange it. So this is, well, I can simplify inside the brackets first. I've got 2M plus 5. The other one I can already expand, so it's 3M plus 15 plus 1. Expanding on the left, I've got 4M plus 10, 2 5s are 10, equals 3M plus 16. To get all my M's together, I've got more of them on the left, so I'm going to subtract 3M from the right-hand side. And what do I have to do with the 10? Well, to get rid of that, I need to subtract 10 from each side. Mia, because 4M minus 3M is just M, so Mia's age is 16 minus 10, 6. Give you a chance to look at it, make sure you followed the steps. All I did was expand the brackets, put my M's together, get them all on one side, get the numbers on the other, and we were done. What do I do now that I know M equals 6? We can go back into equation 2 and equation 1, can't we? So I'm going to say let M equals 6. Therefore, E is going to be 3 times 6 plus 5, which is 3 times 11, 33. Okay, and in the first one, let M equals 6. Therefore, C equals 6 plus 5, C equals 11. And you've got their ages. Mia is 6, Chloe is 11, and Emma is 33. Does it work? Is Chloe 5 years older than Mia? Yep. 11's 5 years older. Is Emma's age triple Chloe's age? Yep. And so the other one, double the sum of Chloe and Mia's ages. So 11 plus 6 is 17. Double that is 34. That's 1 more than Emma's age. So you can even check it and know you got it right. That was a pretty tough section, but you guys have done well. Does it sort of make sense? They're good hard questions, so you should be confident you can do whatever's on the test if you can follow those ones.